video is focused on research-based surveys. And there's a number of research-based surveys in STEM that instructors can use to see how their instruction is impacting their students. And surveys are usually given twice over the semester as a pre-test at the beginning and as a post-test at the end. And if you recall our discussion on the feedback cycle earlier on in this video series, you'll recall that I showed that assessment techniques can fall along a spectrum from providing information more aimed at students' feedback cycles to that of instructors. And here in research-based surveys, most of the information is actually coming to us as instructors, and that's because these surveys don't factor into students' grades and they're not handed back to them. And so they're really helping us understand the impact of our own instruction, and that's the major goal. So research-based surveys fall roughly into a couple of areas. There's content-related surveys as well as attitudinal and belief surveys, and one's focused on student affect. And most of this discussion will actually focus on content-related surveys, though we'll touch a little bit on the other ones as well. And so over the course of this video, you'll get to hear a little bit from some experts involved in the development of research-based surveys. We'll also get to talk to some faculty members who actually use research-based surveys in their courses to give us more of a practical sense of how these things play out in action. We'll start first with concept inventories, and as their name suggests, these surveys focus on conceptual understanding, and a number have been crafted in various STEM disciplines. And before we get started, I have to put a little disclaimer here. You might notice that in our discussion of concept inventories that I'm not going to show you very many specific questions. And this is because these inventories have been designed through many, many years of research. And so we have to take care with showing specific questions, because if college students get access to these questions, then this can really affect the validity of the instrument. And so in the STEM education research literature, there's published papers that have a few sample problems, so that's one place you can look if you want to see a few more specific examples. And most concept inventory creators actually suggest destroying or locking up paper copies of surveys after tallying the results so that students do not accidentally get access to copies. So yeah, just take that as the kind of disclaimer of concept inventories in this section. So now we're going to hear from Jenny Knight, and she's going to talk to us a little bit about concept inventories.
Concept inventories in all fields have generally been designed as multiple choice assessment tools. This is because it's much easier to administer them to a large number of students. Unfortunately, some people feel that the multiple choice format might only allow you to get a relatively low resolution of knowledge about what the student actually understands. So for example, if you were able to do an oral interview on all the students or have them write long essay responses to questions, you'd almost certainly get more information about what they understood about the topic. But because we want to survey possibly thousands of students at a time using a concept inventory, we really need to use the multiple choice format. The multiple choice format works really well for concept inventories when the concept inventories have been constructed carefully. In other words, using student interviews, using student-supplied ideas for incorrect choices, etc. And so at that point, the resolution of knowledge is much higher than a standard multiple choice assessment because of the way it's been constructed.
So concept inventories have many carefully crafted multiple choice questions that come out of a lot of qualitative research and student interviews. And so in physics, for instance, one of the main research-based surveys is the Force Concept Inventory, and this has been around for about 20 years. And so a lot of physics instructors have given this survey in their introductory physics courses. And so something that's interesting is that faculty were often really surprised that their students performed poorly, and this has been a real wake-up call for the physics community that traditional lecture-based instruction doesn't always work. And it's actually spurred a lot of innovation in physics education to help students really learn the concepts in introductory physics better, because we know that traditional instruction just wasn't working. And so it's really been an important part of some major reform efforts in college physics. And each STEM field has its own particular approach to content surveys, but most of them are multiple choice. And these are exams that can be completed in less than one class session.
In biology, we have a variety of introductory level concept inventories. Because biology is a very broad discipline with many subdisciplines, there isn't just one concept inventory that captures all of biology. So people tend to choose one that better matches the content of their course. So there's one on natural selection, there's one on molecular biology, genetics, etc. And these assessment tools, like is true in physics, are commonly used pre-post. So the assessment tool is given on the first day of class and then given again at the end of the class to measure learning gains over the semester.
So it's a really involved process to craft a multiple choice research-based survey. And so now we'll hear from Stephanie Chasteen, who will open up the black box of these research-based surveys to show us how much research goes into them. There's a ton of variation in student ideas and an iterative design process that goes into making a multiple choice exam even possible. And so Stephanie worked on the Colorado Upper Division Electrostatics Diagnostic, or the CUE, and led the original development work that, years later, is now just becoming a multiple choice survey.
So I was involved in creating a conceptual assessment or a concept inventory for a particular course, a junior level electricity and magnetism course. We had some detailed learning goals for this course that included sort of higher level skills like visualizing the problem or choosing the appropriate problem-solving method and being able to justify that choice. So let me give you an example from the CUE. Several of the problems on the CUE ask students not to actually solve a problem, but to choose which problem-solving strategy is best. We didn't want them to calculate because that's tested pretty well on the traditional exams, but we wanted to see their thought processes when they chose which problem-solving strategy was appropriate. So these questions ask them to state the strategy and why they chose that method. So here's an example. We've got a cube, it's charged positively on the top and negatively on the bottom, and we want to know the electric potential really far away from the cube and off axis. Now that's important because it means that it's really difficult to solve this by just integrating up the charge, and so you should use an approximation technique. So we're testing to see whether or not students really know when an approximation is appropriate. Now you'll realize by looking at this problem that we're going to get a lot of different types of student answers, and we're going to get some really rich responses, which is great for getting a lot of insight into student difficulties, but it makes it difficult to grade this in a consistent way. So what we did is we came up with a really detailed rubric for assigning points to each problem. So here is the rubric for this particular problem. So you can see we broke it out into whether they gave the correct answer and what kind of explanation they gave, and we have specific points for different types of answers that they might give, and we argue amongst ourselves as to how many points each type of answer was, and we came up with something that worked really well. And I'll say that this took many iterations because we would grade exams, find one that our rubric didn't account for, and then we'd have to change the rubric. Coming up with a good rubric can take some time, but this ended up being incredibly valuable because we got great inter-rater reliability between raters when they use this rubric to score each problem. Now I'll say that one thing is that this is very time consuming, both to grade and to become trained to grade. So what we've done now that we have all of this rich data on student responses to the questions is we used that data to create a multiple choice version of the CUE. And that multiple choice version is probably what will be more used going forward. But creating the open-ended assessment was really the only way we could have created that multiple choice assessment.